哎，你们看不到。 好，复杂的设定，为什么消掉啊？好 ，OK。So, can you hear me? The students online? Mostly. Okay. All right. So this will be this will be the future way of using of the lecture right now. It's really complicated. And the reason why I need to do this is I need to make some drawings. 我要画图，所以我要把我的 iPad 拿出来，所以才会这么复杂。没有黑板那个问题。Okay. All right. So I hope this is okay for everyone. Looks good. 好，有问题随时反映啊。All right, so last week, any questions before we start? So last week we talked about instruction set, which is this chapter, instruction set. So instruction set is actually the interface between software and the hardware. Have you thought about how the software, how the system implementation or development, how they are done? You have the software programmer writing C code, and you have the hardware engineer building your, let's say, CPU. How do they talk to each other? They don't. They don't, because they speak different language. Like one speak Taiwanese, the other one speak Vietnamese. So they don't really talk to each other. So instruction set is actually the let's say interface, the common language between the two. So how do you let two people, one speak Italian, the other one speak, let's say, Mandarin, talking to each other? 意大利人，你跟一个意大利人讲什么话？怎么沟通？ How do you talk to a person from that's speaking the language that you don't know? So you choose the common language, right? So you talk to the Italian people using English. To speak English, he or she speaks English too. So you can communicate. That's exactly the purpose for instruction set. So hardware designer. So instruction set, what does the instruction set define? Instruction set defines what operations should be supported. 你有哪些 operation 需要被支援，需要可以动 right? So for software programmers, they know, oh yeah, my CPU supports these instruction sets. They can do addition, they can do subtraction, they can load the data in and sort it out, so on and so forth. That's all they need to know. And the hardware designer knows that, okay, when I'm designing the CPU, I just need to make sure my CPU support these operations properly. Then I can talk to software programmer. Okay, so we, software engineer and hardware engineer, they both translate their understanding of the system into this instruction set. 就是两者软硬体工程师他们对系统的理解，在这个 instruction set 这里碰在一起，这个是他们的共识。就是我认为系统，软体工程师认为我的硬体系统长成这个样子，硬体设计师认为我设计出来的系统呢，软体工程师会这样用。Okay, so this instruction set provides a very good interface, abstraction layer interface on how this system works. So that's basically the purpose of this. Okay, and last week we talked about there are different types of instruction set, right? We have Oh, so last week we talked about RISC processor. Remember RISC? Reduced instruction set architecture, computer. And we also talk about talk about CISC. Have we? 我们有讲 CISC 吗 ？CISC. The only different character is this one. It's called this C. It's called complex. 还是很难写。Okay, so CISC and RISC. This R represents reduced. 虽然还是很丑啦字哦，但是比那个滑鼠的字好一点。All right, so we have these two types. For RISC processor, RISC instruction set, there are many different kinds. You have, let's say, MIPS. 有一种叫 MIPS， 有一种叫做 ARM. And one of the most popular these days is called RISC-V. RISC-V, 那个 V 是罗马数字的5嘛，对不对？第5代，所以叫 RISC-V. If you pronounce a RISC-V, then 大家觉得你这个人不懂。那个叫 RISC-V， 这叫 RISC-V。就是你不能讲 iPhone X， 这样，你要说 iPhone 10， 是不是？你讲 iPhone X， 你就觉得你真的是很 X。Okay, so let's go RISC-V. How about CISC? Any popular instruction set that you're aware of? x86, x86 有没有？这里就要讲 x， 这不会讲 x86， 真听不懂。x86 反正 x86。Okay, this is the complex instruction set from Intel. 是 Intel 发展出来的指令集，它是一个比较复杂的。So because it's complex instruction set, it's pretty complicated. I'll show you later on. It's very complicated instruction set, and one instruction can finish 10 operations with only one instruction. 就是它一个指令可以完成一大堆的工作，就是很复杂。一个指令可以做完很多的事情。All right, so that's CISC. And Intel's x86 instruction is actually pretty ugly. It's really, really ugly language or instruction set. It's like patches here and there. I don't really like it. But even though it's a really popular one, 就是这个 x86 哦，其实这个语言非常的不漂亮，我不想说它很丑，就很不漂亮。就是东补西补，就是一个人身上穿的，一个富翁身上穿的衣服，但是很多补了，补这补那边，很丑的一个语言，就是很不 elegant、不优雅的一个语言，就是通常不太有钱，但是它 it turns out to be one of the most popular, widely used instruction set in the world. 它还是世界上最广泛使用的程式语言之一，那个指令集之一。那有它的历史背景，我 can talk about that later. But do you know, even Intel is the founder of that x86, one of the most popular instruction set in the world. Even Intel is trying to develop processor supporting RISC-V. 你知道这件事吗 ？Intel 自己都在开始慢慢往 RISC-V 那边移动。So RISC-V is a very popular one, and we are actually learning this language, this instruction set. All right, so instruction set RISC-V, that will be the instruction set we use for this class. And there are many different instruction set architecture. We call ISA. 这个叫 instruction set architecture. That A is architecture. 不好写啊，不是我自丑，根本不好写。 我字也蛮丑的。So that's called instruction set architecture, and we'll use this as the example to show you how instruction set looks like. So this is a basic arithmetic operation. 这个是加减乘除四则计算。So the format, the default format for arithmetic operation is like this. You have an operation in the beginning, like add here, and you have ABC followed by this add. So that means this instruction is telling the CPU to add B and C, and put the result to A. So all these A and B and C, these in the RISC processor, they are registers. Okay, so the design principle one is simplicity favors regularity. We talked about that last time, right? And we also talked about this example, GH minus I plus J. So you add GH and put into temporary register T0, and you add I and J, put into T1, and then you sub T0 and T1 and put the result to F. Okay? 这个上次有讲写错了啊。All right. So for a register operation, for RISC-V, there are 32 64-bit register files and use frequently data. All right. 这就是我为什么需要看。好。All right. So this is why I need. This is my whiteboard. 这是我的白板。我现在在画图。So in a computer system， 这个档案我可以到时候存档，然后 share 给你，所以你也不用画，我画完你就存档，你自己再看。很丑啦，但是至少看得懂，就是可以让我解释一下什么事情。So in the CPU system, in a computer system, you have a processor called CPU, and the basic one is you have a memory. Okay, so you have memory. This memory you usually are DRAM. DRAM 叫 dynamic RAM. OK， 就是你去官网商场买说我要8G 的记忆体，那个8G 就是 DRAM， 就是8G 插在上面，买2张4G 这样插2个4G 就 8G， 那个东西叫 DRAM. So that's the main memory for a computer system. Okay, so this is a really basic overview of the computing system. All right, so you have the adders, you have multipliers, you have divider, you have these and that operation units inside your CPU, right? CPU can do addition, CPU can do this, do that, but they need to perform this operation on data. 它需要就是加也要有2个东西相加，那这2个东西哪里来呢？ So when you are performing addition, remember the instruction that we have add A, B, C, right? So where are these data in the beginning? So you have add A, B, C. So for the RISC processor, these ABCs are the registers inside the CPU. Remember, we mentioned there are we are 32, 我们有32个 64-bit the register, right? Each one is 64-bit, and we have 32 of them. Okay, so we take this B and we take the C and we'll put it to, let's say, A is here. So that means you take B, you take C, and you calculate the results and you store to A. That's A, that's B plus C, and put it to A. Okay? All right, so now your question is, where is B and the C in the beginning? BC 一开始在哪里？ BC 一开始在哪里？ BC 一开始呢 they are here. B are in the memory. B, they are here. So then you say, hey, why not? Why not? Why do you want to move? So before I can do this A plus B plus C, I have to load B into the processor, load C into the processor, and then do the addition. 我要把它 load 进来 from memory, I load them in, then I start doing the addition. But why do I need to do that? Why not? I just load them to the side and just do this. And then I generate the A. Why not? Why not? 为什么不做这件事？ Because B and C is in the memory, and in memory, the data load is very slow. 它很慢. If you do this from BC load into the adder and then generate A, that takes a long time. So it's better that you load this B and the C to the processor, to the register in there, and working on the register. Because registers, they are, because of register file. Register file, they are fast. 它是快. So because CPU runs fast, so I need to my data to come in a very fast manner. So I have to load the data from the register. Okay. So that's the very brief overview of the computer system. Any questions so far? 到这边有没有问题? Yeah. 你说右下角那个吗？这里啊 ，long latency。这个呢，这个蓝线呢 ，this blue line has short latency。你会觉得很奇怪，那你不是又要从memory 里面把 data 漏进来，然后再算完再存回 memory 里面去，那跟你从 memory 直接拿出来算完再存 memory 不是一样的？你的问题是这个，对不对？好 ，so the difference is when you put the data into the main difference between register file and the DRAM is register is slow, register is fast, DRAM is slow. So when you put the data into the register, you can run this addition at the speed of CPU. 你可以在比 CPU 快的这个时脉去计算。那不同处在哪里呢？ When you load B and C in the register, when you need to do your next computation, let's say, so when I need to calculate the subtraction of C from B, then I don't have to load B and C again. Load B. Load C. So if I want to do addition, I need to load the B and the C first. I load into the register, then I do the computation. Okay? But since B and C are already in the register, if you want to do the next operation called sub B and C, I just need to load it from register, not from the memory anymore. So this add, the very first time you work on B and C, will be very similar performance as the one on the right. 跟右边那个会很像 because you still need to do the load B, you need to do load C. They are slow. This one is slow because it's from memory. This one is slow because it's from memory. This one is fast because B and C are now from register. And for sub D, B, C, for this one, this will be fast because if you are not doing this, 假如你不做这件事的话，你要另外拉 BC 去拉另外的 BC 去做减法的话 ，this will be slow. But this sub will be fast. The one on the left hand side, that sub will be fast. That's the main difference. Making sense? 可以吗？这里就有一个很好的点。那 BC 假如只用一次的话，我就丢了，我需要漏进来吗？ Theoretically, you don't have to, but instructions for RISC instructions you still need to, because for RISC instruction set, the arithmetic operation can only be performed on register. 就是 RISC 指令集，它只让你做加减乘除的运算的时候，你的来源是从 register， 你还是得漏进去。所以 register 我们这边。我们先停在这边哈。Any question about this figure and the concept of the basic comparisons？ 这里有没有 ？Try to 你这边要懂哦，你后面我们的讨论你才可以 follow。You have to understand this, and then later on when we start discussing other further things, then you can follow. Okay, now, right? All right. So here, now we can understand. Now we can understand. We have 32 64-bit register, and they used for 这里就告诉你了，叫做 frequently accessed data. I cannot store anything there because I only have 32. 我就32个位置，我不能把所有100个人都放进来，我只能放32个最常被用到的东西，最有价值的东西。你常用的东西不是都会放在你身边嘛？对，你常常拿手机，你常常这个擦什么乳液什么东西，这种东西你都会放在身边 ，right？ 那你没有用的东西放远一点没关系。So you only have limited space, register space, so you need to keep those data that are frequently accessed in the registers. Okay, so 64 bits is called double word, we know that, and 32 bits called word. 这个是单位的名称啊，32 bit 叫一个 word， 64 bit 32 bit 加一个 word， 64 bit 叫 double， 有两个 double word. Okay, so the principle 2 is smaller is faster because when you load the data, you load it from memory. That's slow. The DRAM is really slow. And register file is fast. 这个快，那个慢。But DRAM is big. Large. SRAM or register file, even though it's fast, but small. 就是有一好没两好，鱼与熊掌可兼得嘛，对不对？就不可能有高富帅这种事情，要把这个问那个，有这种事。Okay. All right, so if you look at the registers, registers in RISC-V. Remember that figure, we have CPU, we have multiplier. Okay. 线上很需要看到我的侧面吗？ These are CPU. You have different units, functional units, and you have the register in there, right? 记得吗？ And there are 32 of them. So these 32 registers, are these 32 registers. 有32个，这32个。They are general purpose, but they also have some specific dedicated purpose. 它一般你可以拿来随便你用，乱用都可以。但是某些 register 它有它规定或有默契的使用方式。They have their dedicated usage. All right. So, the name for RISC-V register they start with X， 就是它是 X 0 X 1 2 3这样下去，它用这样编号。So X0, this one is a really special register. This one is a really special register because it stores 0. X0, 它的值就是0。你写什么东西进去，它不能被写，它就 always 是0。So X0 is always 0, always 0. Now you have X1, X2, X3, X4 to X31, right? They have different ways of using. For example, X1 is used for return address, and X3 is used for global pointer. And 5 to 7, 28 to 31 for temporaries, and so on and so forth. We'll talk about how these registers are used. 它们有不同的功能性。All right, now let's look at the example. So for register operand example, we want to add G and H, we want to add I and J, and then minus them. So that's simple. You just need to know that, okay, this, and you put the result into F. So G is in X20, this one is X21, this one is X22, this one is X23, right? And the F is X19. So again, these are registers. These are registers. That's why it's now CPU. So you have CPU, you have registers. So here is you store X20, you store G. X21, you store H. You store I and J. X22, X23. That's about it. OK， 它长得这个样子。你的 G, H, I, J 它是存在这些 X20, X21, 22, 23 registers in there. So in this case, it's easy to understand this already. You add X20 and 21, you add it and put it into X5. 你把 X20 加21加起来之后放到 X5 在这里啊 X5 you have G plus H and then you have X22 X23 and put it into X6 这边就有 I X6 就是 I 加 J okay and then you subtract X6 from X5 then you have your results in X19. Any questions so far? 这边有没有问题？到这里，可以哈，应该蛮简单的。All right, so memory operands. The main memory used for composite 就很复杂的资料结构 ，array, structures, and data. So to apply arithmetic operations, you need to load the value from the memory into the CPU, do the operation, and then store the data back to memory. 不好意思啊，这边有个 CPU， 这边有个 memory. So you load the data in, you do the operation, and you store it back. You load the data in, you do the computation, and you store the data back. That's how the arithmetic operation works. That means you need to load A, load B, then add A, B, and then store. 这个假设是 C 啊 ，store C。你要把 A B 这个是 A B， 这个是 C， 所以是这样啊，你 load A load B，you add A and B，and then you and put it into C，and then store the C back to the memory。Okay, making sense? All right, so memory is byte address， 就是 memory 的最小单位，一个单位是 byte， 一个 byte 多少 bit？ 知道吗？一个 byte 是8 bit，OK， 8 bit， 可以吗？这个应该我觉得好像有点 confused 的眼神出现，没有啦啊，要吓我，只要有的话要赶快让我知道。Each address identifies an 8-bit byte， 就是它一个单位就是8个 bit， 8个 bit， 8个 bit， 一个单位啊。你的 memory address when you move one position to the next one, that's the next 8 bit. One position is next 8 bit， 一次就是8个 bit 下去，8个 bit 是一个 byte。Okay, a RISC-V is Little Indian， 小印第安，什么意思呢？Little Indian, that's the coding scheme. 这个是一个协定嘛，就是 What is Little Indian? When you store the data, 假设好了123啊，有没有？我假设我要存一个，Let's say I'm storing the data 784. When I'm storing these 3 digits, 3个数字啊 ，should I store 4 in the memory first, or should I store 7 first? 就是我存进去的时候，我的 memory 我一定是从 memory. If this is my memory, this is my address 0, address 1, address 2, address 3, 4. I store the data in to my memory. Each memory location can keep 1 digit. So should I store 4 or should I store 7 first? 我要先存4还是要先存7？没有什么好坏处了啊，就讲好就好。你不要先存4，然后人家是以为你先存7，那就完。784就变487，读出来就变487，就完蛋。So Little Indian is a protocol, it's an agreement. Let's say agreement scheme. So in RISC-V, the least significant byte will be stored to the least address of a word. 就是你的 word 里面的位置比较小的那边是先存比较低位数，就是4会存在，它就会这样存啊，它就会存4、8、7这样子存，叫 Little Indian， OK 吗？讲好就好。Okay, so that's called Little Indian. All right, so Big Indian is the other way around. The most significant bit stored in the least significant address. 讲好就好。RISC-V does not require words to be aligned in memory. 它们不需要对齐，它可以任意的位置。Questions? You have to stop me if you have any questions. Same for students online. So, because today we probably need to finish like 50 slides. 我们今天要讲完50页啊，所以各位等一下会越来越快。我前面很慢，是我让你跟，拜托要跟上，跟不上赶快跟我说。All right, so memory operand example. If the C code, 大家知道 array 吧 ？You know the data structure called array 阵列嘛，对不对？阵列就是 if you have the array, you have if this array is A, then you have array A. if you have array A0, A1, A2, A3， 就是 A 的第0个位置 ，A 的第1个位置 ，A 的第2个位置 ，Let's call array. So this C code your number 13第13个位就是 A12，因为它是0才算。A12 A12 equals H plus A8. So how do you translate this into RISC-V code? Looks like this. So that means you load A8. 你先把 A load A8. 你先把 A8 load 进来 and then you do the add 加法 and then you store the data back to A to memory. Store the answer to A12. OK， 所以是这个意思啊。OK， 这边概念上可以吗 ？Conceptually it is okay because we are going to jump into the code. All right, how come A8 equals this? 为什么 A8 是 x22 的括号64？什么意思 ？All right, so when we are trying to describe the memory address, we have two variables, especially for array. 我们有2个参数，一个叫做 base pointer 基准点，第二个叫做 offset 叫位。我告诉你基准点，然后我告诉你离基准点多远，你就可以找到你要的那个位置。Okay, so that's exactly how array works. I tell you the beginning, the base pointer for this array is A, and this address is stored in register x22. 它 x22 存的是基准点 and 64 is your offset. How far away from this x22 is your data? And the distance is 64. Question now is, why 64? 为什么是64？为什么64 ？A8 8跟64有什么关系？88 64。为什么88 64？我不知道，99乘法表。为什么8要乘8 ？So 64 is the offset. That means I'm 64 positions away from my base. Why 64? Because the first one is 0. If I add 64, that will be 8. 画给你看 A0 在这里。A0 1 2 3 4 5 6 7 8。So A0, this is address 0. So what is this address here? 这个，假如那里是0，这个 address 是多少？64 Why？ 就是 A8 的开头是64，为什么是64呢？因为 Why 64? Because do you remember how large is this each word? 一个 word， 一个 data， 一个 word， 有几个 byte？ 8个 byte 嘛 ，double word, right? We say it's double word because RISC-V support double word. So each variable is a double word variable. So that's 8 bytes. 一颗一格哦 ，A0 这一格就是8个 byte. So if you are A8, how far away are you from the beginning to that A number 8? 64, right? 可以吗？可以吗？哈，我怎么觉得好像有点卡卡？可以吗？可以，可以，点头。OK， 比赞。哎 ，double word 的意思就是这里一个 word， so that's the unit of the data. So a word is 32 is a 4 byte， 4个 byte 拼在一起叫一个 word， 32 bit 这样，这个 OK 吗？ Is it OK? So the size of the unit operated by RISC-V is 64 bits， 它可以运作在64 bit 这么宽的。他有跟你讲啊，一个 data 就是64 bit， 一个 register。One register is 64 bit, so 64 bit has 8 bytes. That's called double word. 它是个单位名称，可以吗？没有，它是算大小、长度而已。它可以是 integer， 可以是 floating point，could be integer，could be different things。他只是跟你说一个 word 是4个 byte， 32 bit 这么多资料，里面到底存什么，你自己再决定。跟哪一个关系？跟 double word 的关系吗？ All right, so the thing is, when you store the 64 bits data， 你假如拿64 bit 去代表一个整数好了，784这个整数，你一定要从一边存到另外一边嘛，对不对？从0存到63嘛，那你那个 bit 0是要放在那个 address 比较低的那一边，还是 address 比较高的那一边？你要先存哪一个？这个是 Little Endian Big Endian 在定义的东西，讲好就好了，没有什么好坏。有人用 big， 有人用 small。In a memory, these are good questions, so I know how fast I should proceed. 就是我要知道这些问题，我才知道我到底要走多快。In a memory, you have a memory address. 这个假设是 my memory. I have address 0, 1, 2, 3, right? I have address. And previously we say one unit of memory is, you still remember that byte addressable? 就是我的 memory 在 RISC-V 里面的 memory 呢，是 byte 为基本单位，一个位置存一个 byte。So this is a byte. This is a byte. This is a byte. This is a byte. So that's byte addressable, 8 bit. So a word will contain 4 addresses. 我假设有一个 word 是4 byte 的话，我就会占掉0、1、2、3 3个位置。If I'm double word, I will take up 8 positions. 我就会占掉0、1、2、3、4、5、6、7，对吗？所以这有解答什么问题？它两者的关系是这样子，所以你有。So if so these will be from here to here, this will be a double word. 0到7这边会存一个 double word. So from bit 0 to bit 63. All right. Where do you store your bit 63 and bit 0? 你假设我是一个整数，我一定是什么11001010这样子嘛，对不对？你那个前面的比较高位数的那个 bit， 你要存在第0那个位置，你才存在第7个位置。存在第0就是叫 Little Endian， 存在第7就叫做 Big Endian。这样子，就是你从这边存回去，还是你那边存回来这样子？你的64个 bit 你要这样子存下来，还是你要这样子存上去？这样。Little Endian, Big Endian. Okay. Questions? 好问题，那我就知道我要快还是慢了。All right. Question so far? 还有没有问题？很快哦，没有。All right. So, make sure you understand the base pointer and the offset. 你要知道 so this is how we specify a memory address. It's how we specify the address in the memory. Okay? So you have a base pointer and you have the offset. All right, so register versus memory. Register are fast to access the memory. You know that. Operating on memory data requires loads and store. 你要运算 memory 值，你要先把它 load 进来，算完然后把它存回去。So you need more instructions. Compiler must use register for variables as much as possible. Because registers are limited. Register 是很稀有的资源，它只有32个，你只能存32个资料在 memory 在这个处理器里面。So compiler needs to decide which 32 which data can be stored in the register. Others, of course, you have to keep the most valuable data inside the register. And the way to determine the value of the data is how frequently you will need it. 你多长需要它，那个东西通常就很重要，你就要留下来。你在接下来的1秒会用到这个 variable 10000次，它很重要。我就要把这个 variable 留在 register 里面，这样我每次需要它，我就去 register 嘛，就很快，不需要大老远再去 memory load。Okay, so only spill the data to the memory. Spill 吐到 memory， 这个是 compiler 的说法啊。compiler 说把资料移掉叫吐到 spill the data to the memory or for less frequently used variable。比较少用的就是不重要的，比较常用的就是重要的。Okay, so register optimization is important. All right. Any questions so far? All right. The other concept is called immediate operand. Immediate 叫常数啊，或者是叫它这里应该叫直接数。我不知道中文怎么翻译，叫 immediate 啊，它叫 immediate. So what does that mean? That means very often you need to add a small number, small value, 小数值，你常常会加4啦，加7啦，加3啦，这种东西啦。For example, if you want to add x22 by 4, that's how it works. You can specify that 4, 你可以直接指定说我就是要加4，你不要再把4存在记忆体里面，然后再漏4进来，然后再相加，不需要。This way, if you can specify immediate value in this way, you can simply put the value inside your instruction. Then you don't need to load that small value anymore. You don't need to load it because it's in the instruction. 我直接就知道我要加4，我不需要去 memory 漏一个东西回来才知道，哦，这个原来是4，不需要这样。我直接告诉指令说我要加4。So this is called immediate operand, and you will find out there will be an I here. That I represents immediate. So one of the operands will be the immediate value. Okay? And this immediate value will have a range. 有一个范围，它不可能是从很大的值负的值到很正，它可能就是2048，正2048到负2048，或者正1024到负1024这种看你有留几个 bit。Okay, so make the common case fast, and small constants are very often used. 小常数，小的数值小的常数常常会需要，加个7啊，加个8啦，加个15啊，这种东西常常需要，你就不需要去 load， 你就直接把它埋进去你的指令说，我就是要加15。它就直接加 ，OK, save a lot of time. All right, unsigned binary and signed binary. 好，这里讲到数字系统，我先问一下各位有没有上过罗瑟？罗瑟有讲过什么 two's complement, one's complement 有吗？ 吗？有啊，这里是要讲这件事，有整数，有复数，有小数是 floating point，这是个unsigned binary，就是没有正负号的值叫 unsigned，so there's no sign， everything is like positive value, there's no negative value， 就是没有负值。So you have 32 bits or whatever number of bits you have, 64 bits. And this is how you can determine the value for that binary integer. 假设这是一个二进位的整数的话，它代表的值就是这个啊，这个应该没有问题吧啊。For example, if you are 1101, that means if this is binary and this will become 多少？8加4加1 13啊。This is 13 in decimal。二进位的1101就是十进位的13，可以吗 ？So this is unsigned。可以啊，那算错了啊。OK。So examples, if you are, oh, there's 有一个例子，1011啊，1011 in binary, if you calculate it, that's 11 in decimal. Okay. So if you have 64 bits, the value you can represent is from 0 all the way to this number. I don't know how to say that. This number is really large. All right. Choose complement is a numbering system to represent negative value. 它可以代表负数、正数跟负数啊。所以 and probably don't have time to jump into the choose complement. You can just go ahead and Google it. So the way to, so if you use choose complement, the same 64 bits, huh? What? 什么问题？为什么会结束？为什么会结束？
好，那希望大家也觉得这个过程好像比较简单一点。
The class， 还有时间，才4页，有点麻烦。Okay, so 2's complement is a numbering system to represent the negative value and the positive value. So it has it's called signed integer， 就是有正负号的，那个叫 sign integer. So it can represent from this value to that value. Okay. 好。All right, 2's complement. For the 2's complement system, the bit 64就是最左边最高位的那个 bit 叫做 sign bit. So that bit, if that is 0, that means it's a positive value or 0. If it's 1, that means a negative value. Okay, 这个应该 OK 嘛？ So, for non-negative value, you have the same unsigned and 2's complement representation. So some specific values here. Is 0 is 0. This is 0. This one, all ones, that's actually representing a negative 1. 它是代表是负1。这个我可能就不跳进去讲解 2's complement 2的补数这个系统，这个应该逻辑设计有教过。If you are not familiar with this, please go ahead and review it. Okay. So this is the most negative value. 1 all the 0 and most positive 1 0 all the 1. Okay, and sign negation. So the way to negate a 2's complement, a positive value to a negative value， 就是你要怎么把你要代表正2，就是你要代表负2的话，你就先写一个正2出来，然后全部把它1变0 0变1，然后再加1，对吧？这个是 2's complement 的做法。可以吗？这边我不要跳进去讲了。2's complement. So if you're still not sure about 2's complement system, please go back to your logic design or check the website. Okay, check the just simply Google. Should be able to find out a lot of tutorials or information about the 2's complement. 这边我就不讲了。There's one very important concept. However, I need to mention it's called sign extension. If you are using 8-bit to represent 2's complement 8-bit to represent a value, and now you want to load it to a 64-bit. 你要从8-bit 的一个值，你要把它变成用64-bit 代表的话， a good way, a very efficient way is to simply extend the sign bit from number 9, 10, 11 all the way to 64. 就是你把那个最高位的那个 bit 延伸，一直复制到64，它就是 64 bit 来代表你这个值的方法。It's called sign extension. So is that okay for everybody? So that means if you are doing this 0011, that's actually 2, right? Decimal 2, 它是2啊，3啊，它是10进位的3。现在是 that's in 4 bits. If you want to do 8 bits, that means you just need to extend this. This is called sign bit, right? This 0 on the most significant bit, that's a sign bit. You just need to extend it. Extend it means copy the same digits. It's 0. So I just copy it. 0, 0, 0, 0. Then that's 8-bit representation for value 3. Okay? If you are having this 1101, that's -3 in two's complement. So if you want to extend it to this 4-bit representation, if you want to extend it to 8-bit representation of -3, then you just need to extend this sign bit to 1111. So that is 8-bit representation of -3. Okay, so that's called sign extension. All right. So for RISC-V, you can have these operations too. For example, if you do load byte, 这个叫 load byte， 你 load 一个 byte 进来啊，你从 memory load 一个 byte. How many bits for the byte? 8 bits. You load 8 bits in, right? How large is your register? The register 多大? We mentioned that in the beginning, you have 64 bits. Okay, so you have 64 bit register, and you just load 8 bit in. What happened to the other 56 bit? 你 load 一个 A bit 进来，但是你的容量是64啊，你填了前面8个了，那后面的54个怎么办？ You can choose. You want to keep them 0, or you want to load it, fill in the 8 bits, and sign extend the other 54. 你可以选你要不要做 sign extension. Some scenarios you need it, some scenarios you don't. 有些你会做 sign extension, 有些不会。你漏进来的假如不是 two's complement, 你做 sign extension 干嘛？对不对？就坏掉了，值就坏掉，你只需要那个8 bit 而已。Okay, so if you do low byte, then this will assume you load a value of a number. So it will extend the sign bit for you. You load a bit, and then it will extend that sign bit to 64. Or you can load on sign, LBU, that's load byte on sign, and that will not extend your sign bit. You simply load 8 bit and it says to you, so you can choose depending on what you need. Yeah. All right. Representing instructions. Question so far. 到这边有没有问题？到这边有没有问题？可以啊。Super slow, super slow. 所以有问题要跟他讲，我要加快了。Okay, so representing instructions. So instructions are encoded in binary. Remember, we have 64 bits. So how do you represent different operations in this 64 bit? 你有64 bit, 你要怎么 represent 你想做的事？告诉电脑你想做的事，你把它编码进去。So you need to encode your operations in. So we call it machine code. Okay, that 11001100. So you have 64 bits. 6320. You have 100110 like this. This is one instruction. What does it represent? I don't know. You need to encode it. Okay, so that's called instruction format. Instruction 的格式，规划。So RISC-V encoded as 32-bit instruction word. 它的指令并不是64 bit， 它的指令是32 bit。这边我 32-bit instruction word. A small number format encoding operating code, register numbers. The important thing is called regularity, 要有规律性。等下你就会看到规律性在哪里。All right, before jumping into the instruction format, let's talk about one way of representing numbers called hexadecimal, 16进位的表示方式。16进位大家知道吗？就是从0、1、2、3、4、5、6、7、8、9，然后会有，然后到15。可是我们没有15，所以我们是 A B C D E F， 所以 F 代表15 ，A 代表10。Okay, so that's called hexadecimal. You have 0, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, and then this is A, character A represent 10, character B represent 11, and then 12, 13, 14, and F means 15. Okay, 这可以哈，0到15。So if you write a hexadecimal 16进位的代表方式这样的话，就代表 this E is what? E is 14, 就是这个就是 E. This one is C, this one is A, this one is value 8, this one is 6, so on and so forth. 可以吗？ So the bit stream down there can be represented in a more clean or easier way as hexadecimal. 你下面那一连串的1001、1001那个东西，你可以很轻易的把它拆成4个一组、4个一组、4个一组，然后用16进位的编码方式去代表它，比较好写，对吧？你写 ECA8 这个比较好写。Okay. All right. So RISC-V format, instruction format. There are different types. RISC-V 的指令有不同的格式，不同的种类。第一个叫做 R type. The first one is called R type. R type looks like this. R is because of the register. R is register type, register format. Okay. So if you look at this, the upper is the format. You have 7-bit for OP code, 5-bit for destination register, 3-bit for function, source 1 register, source 2 register, and function 7 for 7-bit. Okay, so OP code is to represent different operations, operation code. And this one is destination register. And this one, that's source 1, source 2, source 1 register, source 2 register, 两个 source， 你就觉得这是用在哪里呢？就是 A 加 B 放到 C 嘛，对不对？啊 ，register 1加 register 2放到 register 3，所以 register 1、2就叫 source register 1 source register 3就叫做 destination register。Okay, and then you have two source registers and 1 destination register. And then the others will specify functions and operations you need to perform on these registers. All right, our format. For example, if we do this add x9, x20, x21. So these two, 这个是什么 x20 加 x21 and put the results to x9. So which one is our destination? Destination R x9, right? So here destination is 9. 它就是9. And which is register source 1 and 2, x20 and 21, right? So 20 and 21, that's it. And this OP code tells you to do addition, 加法，就这样。And then if you represent this into your instruction, that is like this. This is the 51, 9, 0, 20, 21, 0. 这样下来哈 and you put it together into the 32-bit instruction. This, 这个下面这个啊 that's your instruction machine code. 它叫机器码，就是你要做加法 x20 加 x21 放到 x9 做加法这件事情的机器码就是那一串1001，然后你把它写成16进位，就是下面那个。 Okay, good for everyone, right? All right. The other type, okay, the other type is called I format. I means immediate，就是有那个小常数在里面。我们刚刚说加的小小的4啊，加7啊，那个小常数在里面。Where is that field? That's here. You keep 12 bits to represent your immediate value. 你可以用12个 bits 来代表那个小常数，所以它就会变成是从-2048到正2047，这个对不对？是不是12对？12对 ，OK， 就是-2000到正2000，大概这个位置。You can represent that range, the immediate value in that range, and you can operate that value to one of your source register. So our source one, that's still the source register or base register. 这个是会用在哪里呢？这个可以用在，比如说 x20 plus 1023，我可以加1023，在我的 range 里面我可以加一个常数，然后放到比如说 x2 里面，假设啊，你可以做这件事，你也可以做另外一个事情，去这个叫做计算你的 address。什么时候会在做这件事呢？ If I'm calculating the memory address like this. How do you calculate the target address? You still remember that x22 offset by 64. How do you calculate x22 offset by 64? 你怎么做呢？你就是 x22 的位置，不管是多少啊 ，add 64. So that 64 is like an immediate. 它是有点像小常数，小的常数项，可以加在你的 base pointer 上面，你就算出你的 target address. So in this memory operation, you can also use I type to calculate. So design principle is good design demands good compromises. So different formats, complicated coding. This is different format from the R type. 跟 R type 长不太像，你需要一些取舍了哈，是取舍。But you can keep the format as similar as possible. The other type called S type. S type, S format. S format is to different immediate format for store. 你要存到哪里这个地方啊？你就需要有2个 registers. One is base register address. The other one is the source. 你要存一个指进到 memory 去啊，我需要2个 register. 为什么呢？第一个是我要存的值在 x20，我要存到 memory 位置 x21 offset by 64。所以 if this is a store instruction, I need 2 registers. One is the value I'm storing, 就是我要存的那个值 where is in the register, which register has the value I'm storing, 存。Second is to which memory address. How do I calculate the memory address? I need the base pointer and I need the offset. Okay, so I need 2 registers to complete, to have all the information of this store. 我再画一下。This is your CPU. This is your memory. And you have a register you keep x20 在 x20 里面。So in register x20, you have the value you are storing. You're storing the value 有值，你要存到 memory 里面，那个值存在 x20 里面。假设是777啊，随便。I store the value. I store the 777. That's my value stored in x20. 它在 x20。我要把这个 value store it to the memory. So this x20 keeps the value I want to store, and I need another register to tell me where I'm storing. I want to store it here. And this x21 64 x21 will give me the pointer to this address。它就会告诉我啊，在那个位置，你存过去，把777从 x20里面的777，你把它存到 x21加64的那个位置。Making sense to you? So in this operation, store operation, you need two registers. 好，问题。记忆体，我听不懂的问题。记忆体的名称在 memory 里面会重复到。啊，好，我跟你讲 ，x21，它只是 x21的意思是说 ，x21里面存着你的 base pointer 的值。它不是 x21这个东西哦，是 你的 base pointer 的值存在 x21里面，你把它从 x21里面拿出来，加上64，那你就知道你要存到 memory 里面的位置是在哪里。哎，对 ，OK，so x21 that's how I represent how RISC-V represent their registers. If you recall. Somewhere in today's lecture, we have mentioned that RISC-V has different registers, x0 all the way to x31. So x is the way they use to represent different registers. x21就是 registers 意思，就是第21个 register 这样。OK， 好。OK, good question. Yeah.
为什么 OP 会要7 bit？
我不知道他定义的。他觉得有用，他就有。没有那么多 instructions。不会啊，7 bit 可以放多少？128个 OP 耶。你说太多是不是
？OP 控不是放就是你要
对，我不是只有4则运算而已，不是只有加减乘除，还有什么？即使是加减乘除，都有不同的东西哦。我要不要有 immediate 的加，还是我要加的是 register 而已，还是我要做怎么样的？你去看它的指令集。So if you go check, I cannot answer that saving 7 bits for OP code is too much or too less. I don't know. I cannot answer that question. That's actually the question that's a question of art. 它有点像是艺术。就是我没有办法告诉你7到底是好或坏 ，but that is in the definition. That's in the instruction set definition. They have a community with a lot of computer architects. They discuss, they meet together, discuss and decide. Yeah, we want to save 7 bits for OP code. There are different ways of perspectives of looking at the problem. I cannot say it's good or bad. It's of course the compromises of different opinions. And that's their final decision. They want to use 7 bits. So, yeah. If you're interested, maybe you can Google. Maybe they can tell you why they want to keep 7 bits for OP code. But there, for sure, will not be the single reason. 它不是一个单一原因，说7因为 Lucky 7不是这种，没有办法有一个很单一的原因。它是一个角力或者是各方意见的取舍后的决定。对，它的 format 通常是这样，它有一些原则，剩下的都是角力和取舍。OK， questions so far？
差11是它可以再放位置，因为看前面他说它是 separate。
我们等一下再讨论这个问题。So registers except x0， 除了 x0 之外，其他全部都是你随便你乱用都可以。你想要怎么用就怎么用。你前面有看到他说这个是 save register， 那个是什么？那个叫做约定，但是你不一定要遵守。 你假如不遵守，你自己的code可以跑，跟别人合在一起你不能跑，就这样。你只要跟别人可以跑，你就要遵守，就是 x20到多少，这个就拿来当 safe register， 可以吗？但是你要它拿来做任何的计算都可以，你要拿来存这个存那个都可以，我们之后会看到。So these registers, they are except x0, they are all general purpose. That meaning you can use it for any use that you want, any purposes you want, general purpose. But of course, in one of the previous slides, we mentioned that some registers, they have dedicated purposes. Those are kind of agreement. So if you want to run your program with others, program want to integrate, work together with others, you have to follow the agreement. 它有点像合意书这样子，就是大家都同意这样子用。但是你要拿 x21来做一些奇怪的事情也可以，但是你要么不要让人家发现你拿 x21来做，这样我们之后看到就会是这样 ，x21可以拿来随便做什么事都可以，你只要不要让其他外面的人发现，就是你对你做坏事之前就是偷偷的做，做完之后把所有东西复原，就是这样，就这个意思。等一下我们会看到有这件事情，那这个学计算机组织还可以教你怎么做坏事，然后不要让人家发现。All right, so store program computers. So this is to tell you the concept that instructions are also data. 就这些指令，有没有想过这个 add x1, x2, x3. Where is this instruction? 这个指令在哪里啊 ？Originally, it's in memory. 它在 memory 里面呢，你要把它 you have to load the instruction in and then operate on it. So instruction is also data stored in the memory. Okay, so this is tell you that. So program can operate on program. For example, compilers, linkers, they can operate on the program. 就是程式可以 operate on 程式，你可以用程式来 generate 程式这样。Binary compatibility allows a compiled program to work on different computers. If they all follow the same format, 就是我们都 follow 这个 format, instruction format. After I translate it into machine code, all the processor can understand what you want to execute. 就是这个，我只要照这个编码的话，只要是 RISC-V 的处理器，支援这个处理器指令集的这种处理器，它都可以看得懂，它都可以执行。所以你编出来的码，编出来这些程式码就可以有可惜性，这个叫可惜性，不是可惜性，叫做相容性啊 ，compatibility 就可以相容。All right. So some logic operations I quickly go over. So you have some logic operation, for example, shift left, shift logic left, shift logic right， 就是往左移几个 bit， 往右移几个 bit， 这样啊。然后有做有 and, or, XOR, or not， 这个是逻辑的 operations 就可以做。Okay. Let's look at shift operations. The format looks like this. I think that's I type. 就是用 I 的 format, I format. You can see the immediate there. So immediate field here will define or determine how many bits you want to shift to the left or shift to the right. 你往左移，往右移。你那个64 bit 的 data， 你可以往左移几个，往右移几个。就是往左移的话，就是右边要补0嘛。往右移的话，就是左边要补0嘛，对不对？补0或补3 extension， 看你要做什么事。你们知道 shift 往左 shift 1格等于乘以2吗？你知道吗？你的 bit 往左 shift 1格等于乘以2，你知道这回事吗？这个是多少？2，这是多少？4，这是多少？8，神奇哈！我看到有人好像觉得哇，好神奇啊，魔术。 往左 shift 一格是乘以2啊，那往右 shift 一格呢，除以2。For integer, if you shift to the right, it's like divided by 2. If you shift to the left, it's multiplied by 2. 就像你的分数是60分，你只要往左 shift 一格，就变600分嘛，对不对？往右 shift 一格就变6分，就是它的一格在 binary 是乘2除2，在十进位是乘10除10嘛，对啊，这没有什么魔术在里面哦，没有魔法，它就是这样 ，OK。All right, so AND operation, if you look at this, 半个小时给你讲。AND operation, if you look at this, I can do is I AND x10 and x11 and then put the result to x9. 我把10、11 AND 在一起，然后放到 x9。So I AND this x10 x11. So if you do bitwise AND, 你把这边都 AND 起来的话，它就是剩下这个1跟1的 AND 才是1嘛哈，0跟1的 AND 就会是0。Then you have 0, 0, 1, 1. So what does want to do? 这个有想要做什么事啊？他其实想要做说 the purpose for this operation is I only want to keep the 4 bits in a certain 4 bits in x10. 我只是想要把 x10 里面的某4个 bit 留下来，其他全部设成0。他想要做这件事。So I only want to keep these 4 bits in x10. All the other bits, I want to set them to 0. So I create a mask and store the mask in x11. 我制造了一个遮罩，一个有点像帽子一样的东西。我只看这个地方，其他都不看。So I create a mask in x11, and in x11 you only have 4 bits as 1 here. So that means this are the 4 bits I want to keep. All the others, I want to remove them or reset them to 0. So then you have this. You'll see that, oh, okay, here in x10, they also have 1. They also have 1. But after you end with the 0, comes 0. Doesn't matter you are 1 or 0, they all become 0. Make sense? So you can use this to mask out the bits. Anyhow. All right, you can do OR. That means I need to have, I want to set some of the bits to 1 and leave others unchanged. 某些我的 x10 里面，我要把某些地方设成1，其他的全部跟原来一样。You can do this. So like here, you set this 4 because if I set my mask x11 to be these 4 bits to be 1, then doesn't matter what bits are for x10, they will be all set to 1. 就是我只要这个 x11 里面这4个 bit， 我不管 x10 那个相对的4个 bit 是什么，它全部都会变成1。因为0和1 OR 起来变1啊，1和1 OR 起来是1啊，所以全部变设成1。Okay, okay, so with this logic operation, you can do a lot of bitwise operations on the data. Okay, 可以啊。XOR 就是 exclusive OR 啊，就是不一样的时候才是1，一样就是0。假如2个 bit 是一样的，答案是0；假如不一样就是1。Okay. So you can use this to negate the bits, leave others unchanged. 就是我只要把这个地方，这几个地方啊，变成是反向的，其他都不变。看哦，假如11，10和 x12嘛哈 ，negate some bits。这个好像不对哦。 这个12应该是只有这一区是1，其他地方都要是0。这个其他地方都要是0。你们回去看一下啊 ，XOR 应该是这样。假如你和1去 ，if you XOR with 1，if you originally are 1, that becomes 0. If you originally becomes 0, it becomes 1. It's a negation. 你和1去 XOR 的话，它有点像是反 not gate not。那你和0去 XOR 的话，它就不动。XOR 你们知道吗 ？XOR 知道吗？就是1 XOR 0的话，那就是1嘛，那叫0 XOR 0，或0 XOR， 然后是1 XOR 1，就是0。这个 OK 吗 ？XOR operation 这可以哈。所以我只要给你一个 XOR 0，你这边是 A， 假如 A 是0的话，那就是，假如 A 是0的话，那0它变成相同还是0？假如是1的话，它是1。A 角是0 ，A 角是1的话，那答案是1，对吧？所以它就不动。假如你是 XOR 1的话，那 A XOR 1的话，那 A 就会反向。这样，对吧 ？XOR 很陌生 ，XOR 很重要的一个 operation， 非常重要的一个 operation， 对，有很多 magic 在里面。Alright, conditional operation, so you can branch. That means 这里也讲一件事情，叫做 sequential programming model。I want to mention one thing, so sequential programming model. So when I execute my program, 有人写啊，好，我问你 ，What's value of C? What is the value of C in this program? 你看得到吗 ？In this program, what is the value of C? C 的值会是什么？6还是8？ 7哪里来7？ 7，而且7啊，对不起，7或是7，搞错了，7或是6。7为什么是7？它比较后面，谁告诉你站在后面的人就比较慢执行？谁告诉你？有人曾经告诉过你这件事吗 ？All right, very good. That's the point I want to discuss. 我就是在讨论这件事情。Who tells you？ 假设我们编号了哈，编号1、2、3、4、5。So I have the number for different instructions. Who tells you? Who tells you? You said that C should be 7 because C is the instruction 4 is after instruction 3. So the value of C should be A plus 3. And then since A is 4, then C should be 7. All right. So who tells you instruction 4 should be executed after instruction 3? 谁告诉你？你们从来没有想过有的时候你被制约化了。谁告诉你4一定在3后面做？ 但是你心中就觉得，这件事是应该要这样子的，谁说的 ？So first, try to challenge, OK? Try to be 抱有一些怀疑的心态，try to challenge。为什么？谁告诉你的？谁告诉你？那你会这样认为 ？That's normal, but why？ 你说好这样，我为什么会这样想所以我为什么会想4在3后面执行 ？Why I'm thinking, I think, I feel instruction 4 should be executed after instruction 3. Why would I think in that way? There must be an assumption to support this thinking. 它一定有一个假设来支持你这个想法。What's that assumption? What's that assumption? 这个很重要，从来没有人教我，技概什么程式语言都不会有人教你这件事情。它叫做 sequential programming model， 叫做 sequential program 写程式啊 model。这个是人定出来的这不是就是物理现象，它不是它不是物理现象，它是人定出来的。So there once upon a time, the people got together, they agreed that the later instruction should be executed only after the previous one is completed. This is called sequential programming model. 这是人定出来，我跟你讲好的，就是我那个第4个一定要在3完成后，我才能做。这件事叫 sequential programming model。好，这件事既然人定出来的，可不可以打破？可以我们这门课后面就会跟你讲，这件事是可以打破的，只要你不要让人家知道就好。好。Let me ask you, what's the purpose? 我为什么要定这个 sequential programming model? 不是很自然吗？就这样子我为什么 ？Why？ 为什么有一群人他定了有了这个协议，然后后面人家照做？这件事为何发生？这个都很重要你要 always challenge yourself, challenge everything, okay? Challenge whatever I say. It's not I'm 100% right. 我讲的有时候是错的，我是故意讲错的，看你们发现。下一堂课我再来更正。你要 always be challenging different things， 不要人家说什么就很相信。好，那所有你认为理所当然的事，通常都不那么理所当然。你要去想想后面会有一些很隐含的假设在后面。那这个假设是什么？为什么会有这个假设？这个很重要，你要有这个能力，就不要人家人云亦云。好，为什么要 sequential programming model? Why we need a sequential programming model? Again, that's an interface between programmer and system. 它是为了在系统和写程式的人，系统就是你的电脑，中间制造一个合约，就是 your CPU, whatever your system is, whatever your computer system, your laptop is, please behave in this way. Whatever you want to do, please behave or operate in this way. So I am a programmer. 我写程式的人。When I write my program, I can assume my program can be executed in this way. Why do I need that? So I have the sequential model, then I can reason, I can predict what will be happening for my code. 我就可以知道我写的程式它的行为是什么。你不用跑，我只要自己 trace code， 我就可以 trace 得出来它的结果应该会是什么。可以吗？这个是它的原因。 而系统设计者就要确保你的系统的行为有符合这个东西。我跟你说，系统设计者有那么的听话吗？没有，他们都在破坏这个规则。它里面在执行的时候，它就是不这样子执行，但是最后结果出来，要让 programmer 觉得，你好像是这样在执行，就是阳奉阴违，就是计算机组织教你的第2堂课叫阳奉阴违。你听懂这个成语吗？就是表面上好像我符合你的要求，是私底下我就乱搞一通哦。虽然 computer organization 蛮适合去从政。Okay, so that's the reason, but it's not necessary. So this C equals 6, C equals A plus 3 should be executed after C equals 6 is done. 所以这件事叫 sequential format， 很重要哦，很重要哦。好，那我们回来。Okay, so this is called branch. Branch 是跳跃。So yeah, if I write several programs, if I do add, if I do add sub mod load several. 我这样的话 if I have a series of instruction based on sequential programming model, I should execute the next one after the previous one is completed. One after the other, one after the other. What if till somewhere I want to skip the instruction of this instruction, I want to jump here, jump to the other the next instruction. If you want to do this jump, 你在你的程式里面一定会遇到这个现象 ，called branch. This is called branch. 什么时候会发生这个现象 ？If a is larger than 0, then I do this triangle. Else, I do this. 你会不会写这个？会嘛？假如 a 大于0，我就做三角形，要不然我就做正方形。所以依照你的 ，if you based on the sequential programming model, square is triangle is here, square is here. You could sometimes execute triangle and jump over square, or you jump over triangle and execute square. 你一定是这边或那边嘛，对不对？对嘛？你一定是你的程式一定是这样执行到这边，然后 if 怎么样的话，我就是三角形，然后 else 的话，我就是这样执行下去，对不对？所以你要嘛就是执行到这边，你要嘛就是这样执行下来，然后跳过来执行，要不然就是你就是这样执行到这里，跳到这边，跳到这里，然后开始执行，对不对？你要嘛，对不对？你要么跳过三角形，要不然跳过正方形执行，对吧？这有看懂啊？三角形、正方形可以啊。All right, so you need a branch. So this is how that branch is implemented. It's called branch instruction. So BEQ called branch if equal. If R register 1 equals register 2, then I jump branch to label 1 L1 是一个位置，有点像 pointer 这样，只在就是假如 R1 等于 R2，我就 jump 到正方形那边去。假如没有，我就继续往下走。And BNE is called not equal， 只要相等就跳，或者是不等就跳，这个叫 branch。Okay. All right. So compiling the if statement. So if you have a C code, you got a C code. If I equals J, then I do addition. If otherwise, I do subtraction. 相等我就加，要不然我就减。看得懂这里吗？相等我就加，要不然我就减，然后 ，OK。 So if you translate it into the RISC-V code, it looks like this. If not equal， 假如这两个不等，这个一定是一个是 I， 一个是 J 嘛。If they are not equal, then I jump to here 做减法。这是 else jump to else。OK。Else I jump to here, do the subtraction. Otherwise, I do addition and then jump to exit. 这个会不会太复杂？假如相等，假如不等的话，我就跳到 else 那里去做减法。假如相等呢，我就先做加法，做完加法之后，你看这里了哦 ，if 你做完加 ，if you finish the addition, then if you don't have this branch equal, that means the next instruction will do the subtraction. 就是你一直往下做嘛，对不对？你不跳过那个减法的话，你就会做完加法之后再往下做，就又把减法做回去，所以就不对。所以你会变成，你要么跳过加法，去直接做减法，要不然就是做完加法之后跳过那个减法再往下走。可以哈，就是做这件事情。All right. And the instruction for this BEQ is comparing x to x. 我把 x0 拿来跟 x0 比，我拿自己跟自己比，然后问我自己跟自己比是不是相等，一定相等。所以这个叫做 unconditional， 它一定会跳，跳到 exit， 跳到出口。这个叫 unconditional 的 branch。虽然它看起来是 conditional 和 unconditional 就是一个可能跳可能不跳，叫 conditional。So it could branch or could be no branch. That's called conditional. Unconditional is you always branch. Unconditional. 但是看起来是 conditional， 但是它其实是做 unconditional， 绕口令。Okay. All right, compiling the loop. 这个地方啊 compiling a loop statement. So C code is while we do the save equals k I plus 1. If the array variable equals the value k, then I will increment. 我就把一个东西再加。So this one, 等一下啊。我们可能要至少要到 sin 这里。看来我们礼拜四要上课，太落后了，很慢。我在13上面跟大家讲。So you compare it to the array to a value k. So here is how this code is translated into the RISC-V code. So first one is you shift logic to the left by 3. 你往左 shift 3个 bits 等于4乘8，对不对？ You multiply by A. Why do you multiply by A? Because one memory position accounts for 8 bytes. It's double word. 你还记得刚刚那个吗？一个 double word 就占8个位置，所以你的 array 的下一个位置会在前一个位置的8以后加8，它一次跳8。Make sense? All right, so I take this x22, that's my index. 我的 index 往乘以8，我是第几号嘛？第一个 element 还是第二个 element？ 这个小是 save， 我这个是 A byte， 这个是 save 0 save 1 save 2，每一个都是 A byte。So every element in the array is 8 bytes. So I have to add 8 add 8, add 8. If I want to jump to the next element, that's 8 byte away. 就加8，加8。你怎么加？你怎么把那个值算出来呢？就是 index 假如是0，0乘以8， 1乘以8， 2乘以8，你要乘以8，你才是那个 offset. So you have to multiply by the index by 8 to get the offset. Okay? So that's the first operation. You multiply the index by 8. And then you add the offset to the address, to the base pointer. You add the offset to the base pointer. This is your base. This is your base. You add the offset to the base. And then you load the value as safe. You load the safe I. You load the value in. And then you compare with K. K is in X. K is X. You compare with K. If K is equal, then you increment the I and then jump back to loop. Okay? And you keep on doing this until you compare safe I is not equal to K. 直到这里 B and E not equal 成立，那就跳到 X。Questions? Any question on this one? I seriously recommend you to do the preview. 就是我觉得应该没有人 preview 这个东西了，就是 preview 就是预习的意思，从来没有人看过这个东西，今天是你人生中第一天看到它，对不对？这样会很慢，这样真的很慢哦，我们的课进展会超级慢。那希望大家可以去预习，再来看，要不然我在这里会停很久。Alright, so that's about the compiling the loop statement. We have several slides to finish. Basic blocks. So a basic block is a sequence of instruction with no embedded branch or no embedded targets. 就是 basic block 意思就是我中间没有 branch， 我中间没有任何的 branch. So if I enter the entry, the basic block, that means I have to execute all of them because there's no branch inside, so there's no chance that I branch out. 就是 basic block 的意思就是说我执行了这个 basic block 里面第一个指令之后，我就会执行全部，因为中间跳不出去，中间没有任何 branch。所以它执行第一个就代表全部会执行的，它不会中间执行到一半else， 所以就跳掉，它不会有这种东西，那叫 basic block. Okay, so the compiler identifies basic blocks for optimization, and then this processor can accelerate execution of basic blocks. Basic block 给 compiler basic block gives compiler more information about these programs. That means when if these 10 instructions, they are in the same basic block. That means I need to execute all of them. 我会执行全部。但是呢，假如我知道你一定会，假如我知道这10个指令都一定被执行的话，我就可以有一些优化可以做，就是我有地方我可以先执行后面，再执行前面，因为我不用担心会执行到错的东西。这个呢，这个我们之后再来讲。Basic block, but keep the concept that basic block is the block that has no branch inside. That means if you are in there, that means all the instructions will be executed. Let's go basic block, and you have some optimization. More conditional operations 有各式各样不同的 conditional 的条件哈。Branch less than 小于 branch greater or equal 大于等于，有这种东西奇奇怪怪的比较啊，自己去看。Okay. All right, sign and unsign. Let me ask you a question. Zero, 1, 1, 1, and 1, 0, 0, 0, 0. Which one is larger? 哪一个比较大？第一个比较大 ，Why？ 啊，正的，我没有跟你说这个是什么 numbering system。Okay, good question. Good answer and good observation. So that's what I'm trying to ask you. If I don't tell you which numbering system I'm using, 0111 and 100, I cannot tell which one is more positive or negative or which one's larger. 我没有告诉你哪一个数字系统，我使用的是哪一个数字系统，所以0111代表什么意思是不知道的 ，undefined. So before you can answer which one is larger, you have to ask me which numbering system you're using, two's complement or unsigned. If this is two's complement, 假如是有正负值的 two's complement 的，像这种，那 yeah 我知道第一个是正的，下面那个是负的，所以正的一定比负的比较我们说比较正比较大，靠近正比较大。那假如它是 unsigned 呢，一个是7，一个是8。假如它是没有正负值的话，上面这个是7啊，下面这个是8啊，下面那个比较大。所以 make sure you know you are dealing with signed number system or unsigned number system. Okay, that's important. All right, I think I need to stop here. 我就停在这边啊。Because this procedure call 我只要讲下去，应该就会倒了。这后面很麻烦。这边要开始教你做人的道理，很复杂的，就是怎么样那个阳奉阴违，你们要记得这个词。假如你不懂什么叫阳奉阴违，赶快回去 Google 一下什么叫阳奉阴违。All right, so I'll stop here today. I have to go back and evaluate if we need to have the class on Thursday or not. If I do, I will announce it on E3. Okay, pay attention to the E3 announcement. And strongly encourage you to do the preview. 拜托，要复习，要预习啦，也要复习啦，赶快追上来，不要这样很慢，因为我都看到你们很迷惑的眼神，不知道是故意的还是怎么样，就是一直让我觉得你很疑惑，所以我就一直 repeat 简单的事情。Okay, I will likely see you on Thursday.
第一个是想要说，I the instruction set 跟 instruction set architecture